So what we want to do now is look at how we can put our complex numbers into a graphical form. So what we do use to do that is what we call the Argand diagram. So named after, I think, a guy named Argand. He did a lot of work with this. I think it was in the 19th century. So basically what we want to do is treat it like a Cartesian plane. So pretty much like a number plane we've dealt before. Just the idea that the real part of a complex number we plot on the x-axis. So the x-axis we call the real axis. So we can label it with an RE there. And the imaginary part of a complex number is on the y-axis. So it's on the vertical axis there. So if we look at the points here, 5 plus 4i, we go across 5 and go up 4. 3 minus I, go across 3, go down minus 1. So go minus 2 plus I, so cross to minus 2, up 1. So up 1 on the imaginary. So there, and this one's minus 1 plus minus 3i, or minus 1 minus 3i. So you can see how they're relating there. So the real points here, so if you plot these ones, I would just be 0, 1. So that's what I relate to. Minus I would be 0, minus 1. That's what I relate to there. And if we have a look at 2 plus I, there's 2 plus I. 3 minus 4i, so 3 minus 4i. 2 minus I, and minus 4 plus 3i. And if you say, have a look at the two conjugates here, well, that's a conjugate and they're conjugates as well. But if you notice something about conjugates, really what we wanted you to realise that they are going to be reflections in the x-axis. So they'll reflect each other, so they'll be exactly the same distance away, except they're just in the opposite direction, but they had the same real part as we go through there. So that's how we're going to plot some values there on the Argand diagram. Now we're going to use the Argand diagram for a lot more later on, but that's how we get a number that's in its real and imaginary parts and plot it on the on the diagram.